Hello and welcome to 10.7 Notes. Today we're going to write equations of circles in the coordinate plane, and also given equations of circles, we're going to graph their attendant circles. Okay, so let's start off with an easy example. Let's say you have this circle with the center at the origin. Okay, circle with the center at 0, 0. Okay, well, within this circle, here's the radius of the circle, right? The radius is from the center of the circle to any point on that circle, and the point on that circle is, I don't know, let's just call it xy for now, okay? So we have a point on the circle called xy, and I would like to ask you the question, how long is this red line segment? What is the distance from here to here? What is the distance from here to here? Okay, this I think would be much more lively if this was a real demonstration, a real class. But obviously, if you've missed class, I think this would be a good review. But if this was, a real class, like I said, and we were in a real class session, I would pause and I would actually wait for an answer and wait for one of the students or wait for you folks to think of an answer. What is this distance? Okay, well, for the sake of this presentation, I'm going to continue, and this is the way I'll kind of explain it. This is the point xy. Well, let's pretend it's the point, I don't know, say 4, 5. Just for the sake of argument, this is the point 4, 5. So if this is the point 4, 5, how long again is that line segment? Well, if this is the point 0, 0, okay, and it is because it's the origin, then the distance from here to here must be 4, right? I went 4 over, and then I go 5 up, right, to get to my point 4, 5, right, to get to my point 4, 5. It must be 4 to the right, and then 5 up. Well, bear with me for a moment. So again, if I'm pretending this is the point 4, 5, then this must be a distance of 4, and this must be a distance of 5 to get to my point 4, 5. So, my question to you is, if this is the point xy, then what is this distance here? Okay? Well, it must be the distance x, whatever it is. If this was the point 6, 10, then this would be 6, and this would be 10, correct? So, next question would be, what is this distance here? Well, it's the distance y. And as you can see, we've made a right triangle. And isn't that amazing that we're going to be coming up with the equation of a circle, but yet we're still using triangles to come up with an equation of a circle. So we can still fit triangles into circles, okay? And so we have this triangle, and using the Pythagorean theorem, we have one side squared plus the other side squared is equal to r squared, right? That's the Pythagorean theorem. So we have x squared plus y squared equals r squared, and that is the equation of a circle with the center at the origin, or the center at 0, 0. So the equation of a circle with the center at 0, 0 is x squared plus y squared equals r squared. Okay? But what if the center is at another point? For example, what if the center is not at 0, 0, but it's at some other location, hk, for example? Okay, it would look something like this. So please draw down this prompt, and remember again, as usual, you're in total control of this presentation. You can pause it, fast forward, rewind, whatever you'd like to do. So you can pause it now if you'd like and draw down this prompt, but for the sake of this presentation, I will continue. Okay, so this circle is exactly like the previous one, except now the center is not at 0, 0, right? 0, 0 would be right there. That would be the origin. So the center of the circle is no longer at the origin. It's at some other place. What is that other place? I don't know. It's hk. Okay? So we're going to go through the same exact thinking process as the previous example where the center of the circle was at 0, 0, but now we're going to do the same exact thought process, but where the center is someplace else, for example, HK. Okay, so I'll ask the same question. What is this distance? Okay, what is this distance? Well, for sake of argument, let me just pretend that this is the point 13, 15. Okay, I'm just making up random numbers. And let's say this center here is the point 9, 10. Okay, so what is this distance? Okay, well, if this is the point 9, 10 right here at the center, then this from here to here must be 9 long, obviously. And then from here to this point, right here, coming down here, I guess I missed it, dropping it down here, this distance must be 13. So this distance is going to be 13 minus 9, okay, which is obviously 4. So, bear with me a moment here. So this distance would be 4, okay, for example. So in a generic fashion, in an algebraic fashion, if we didn't know the exact coordinates of this endpoint of the radius and the center of the circle, all we knew was x, y, and hk, what is this distance here? Well, it would just be x minus h, right? It would be whatever this value was minus whatever that value is, and that would be this distance. Okay? I think, again, that this would be better demonstrated in class, but, well, obviously, since you're not in class, I think this is the next best thing. So, you know, and of course, at any time, if you're not understanding this, then, you know, come up to me, and I would love to help you. Okay? It would be my pleasure to help you out. All right, so getting back to this, what is this distance here? Okay? This distance here, similarly, just like this is x minus h, this is going to be y minus k. Okay, you take this value, subtract it from this value, and you get this distance here, y minus k. And again, just like the previous problem, this is a right triangle, and using the Pythagorean theorem, you have one leg, quantity squared, plus the other leg, quantity squared, equals your radius squared. In other words, x minus h quantity squared plus y minus k quantity squared equals the radius squared. And this, ladies and gentlemen, is the big teaching point of today. That is the equation of a circle with any center, which we're going to call hk, and radius r. And by the way, the only thing that you need to define a circle in a two-dimensional space is to know where its center is and its radius, right? So, in other words, if I know that the center is here and the radius is that much, that's all I need to know to make a circle, right? I would take the needle of a compass and put it here, and then I would take the pencil portion of the compass and put it here, and you can draw a circle, okay? Or if the center of the circle was here, and I knew the radius was this much, for example, then that's going to be a little bit off the paper, but say if it was here, and this was my radius, then I know that that's my circle, okay? All you need to create a circle in any two-dimensional space is to know where the center of that circle is going to be and the radius of that circle. Again, all you need to know is the center of the circle and the radius of the circle. So if I have the center of the circle, hk, and the radius of the circle, then again, that's all I need to know, and that is my equation of a circle. That will tell me exactly where the circle is in any two-dimensional space and exactly how big that circle is. I mean, the exact circle. This is like a photograph or a picture or a formula for defining a circle. Okay, it's the formula for the equation of a circle in any two-dimensional space. And this is the teaching point of today. So I hope you'll understand that and hopefully get an appreciation of where it's derived. It's basically derived from the Pythagorean theorem. Okay. In the next frame, we'll get into specific problems that you will see. So here are some typical problems that you might get. Okay, write a standard equation of a circle given the following center and radius. So we'll start off with a simple problem. This is one where the center is at 0, 0, and the radius is 2.5. Well, if you refer back to the first frame of this presentation, you will see that the equation of a circle with the center at 0, 0 is simply x squared plus y squared equals r squared. So the equation here is just going to be x squared plus y squared is equal to 6.25 because 2.5 squared, 2.5 squared, is 6.25, okay? So that's the easiest type of problem you can get, okay? A more advanced type of problem is one such as this, where the center is not at 0, 0. In this case, the center is at -2, 5. So remember the generic formula or generic equation for a circle is x minus h squared plus y minus k squared, where h and k are the center of the circle, and radius squared equals radius squared. So plugging in your values, you have x minus h, and this is your h, so it's x minus -2, okay, x minus -2, and x minus -2 is x plus 2, okay, that's where you get the x plus 2 from. And then it's y minus k, and k is 5, so it's y minus 5, quantity squared, is equal to your radius squared, or 7 squared, which is 49. Okay, so that would be the equation of this circle with a center of -2, okay, because it's x minus, well, if the template is x minus, then it must be x minus -2, okay? So this has a center of -2, comma 5, right? -2, 5, so that's the center, -2, 5, and the radius is the square root of that value, which is 7, okay? And then there's this type of problem, which is the probably one of the most difficult types of problems we can give you in this format. Okay, so this one says there's a point on the circle, 3, 4, and the center of the circle is 1, 4. So remember, the equation of a circle is x minus h, quantity squared. So again, I want to repeat, this is the equation for a circle, x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared. And so we have hk, the center of the circle, and I have the center of the circle right there. So my h is 1 and my k is 4. But the piece of information that I need, which I don't know, is r. What is the radius? Okay, I don't know what the radius is. So if you draw this little diagram here, okay, you could see that the center is at 1, 4, and that there's a point on the circle, 3, 4. Well, what is this distance here? Because that distance would be the radius, correct? Well, the radius is just going to be this 3 minus 1, right? 3 minus 1, it's going to be a radius of 2. Okay, so sometimes you're going to have to use a point on the circle, and you would just actually use the distance formula with the point on the circle, using the point on the circle and the center, use the distance formula to find the radius. Okay, so the radius of the circle is 2, and so now we can fill in the values that we know, and we have x minus 1, quantity squared, plus y minus 4, quantity squared, equals my radius of 2 squared, which is 4. Okay? And the last type of problem that you'll get is Well, given the equation of a circle, you need to graph it. Okay? So the first thing you need to do is to create a coordinate plane and get yourself ready to graph the circle. And then you need to find the center of the circle. Okay, in this case, the center of the circle is 4, -3. Because remember, the equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, equals my radius squared. Okay, where h and k are the center of the circle. And so in this case, it's x minus 4. So the 4 is going to be my h value of my center, right? And then for y minus k, okay, this portion here, it's y minus whatever that value is. But in this case, it's y plus 3, so that must have been y minus -3. Okay, so it's -3 there. Give me a moment here. Let me erase these values. Okay, so we have the center is 4, -3, and the radius is going to be the square root of, hold on, I got a little bit ahead of myself here. The radius is going to be the square root of this value here. The square root of 16 is 4, so my radius is 4. So now I know everything that I need to know, or I have everything that I need to know to create the circle itself, to actually graph the circle itself. Okay, I know the center and the radius. So there's my circle, with the center being 4, -3, and the radius is 4. Okay, and again, that's another type of problem you'll get where you're given the equation of the circle, okay, like right here, and you need to graph the circle itself. So that's sort of like the opposite of what we were doing before, where you were given the circle and then you had to come up with the equation of a circle. So you need to know how to do it going both ways. Okay, so that's the end of the presentation. Again, if you have any questions or concerns, please feel free to contact me at your convenience, and it would be my pleasure to help you. Okay, bye-bye.